Good afternoon. My name is John Maloney. This is assignment 1 of Introduction to Ammunition and Ballistics, Basic Ballistics. The two references that I've used today are SOCOM's Door Gunnery Guide and the Introduction to Ammunition and Basic Ballistics workbook through SDI. Moving on to part 1. So the 4 steps of ballistics as I know them are internal, transitional, external, and terminal. Internal ballistics consists of like everything that's inside the cartridge itself of the weapon. So like the weight of the projectile, grain counts, type of rifling that you have in your weapon, the rifling rotation ratio, composition of the bullet, and the type of bullet that you're using. Transitional starts when the projectile leaves your muzzle, and it ends when pressure in the barrel equalizes to atmospheric pressure. Transitional mainly affects muzzle flash and your initial velocity of your projectile. External ballistics is everything that happens after the projectile has left the muzzle. So wind, rain, snow, dust. In my case, it could be rotor wash or like the spin of the barrels of the minigun. And terminal is what happens to the projectile after you've hit your target, and further. So what happens after the bullet makes impact. Things that can affect this would be the type of material that you're shooting, be it armor plate steel, armor plates, ceramic, flesh, bone, pretty much anything that could affect how that round is going to move through it. Moving on to part 2, we'll go on to sectional density. Well, what really is sectional density? By book definition, it is the ratio of projectile's mass to its diameter. In layman's terms, what this means is that a greater mass to diameter means you have a higher penetration. So a high SD equals more penetration, and a low SD means less penetration. In regards to sectional density and armor-piercing rounds, when talking armor-piercing rounds, sectional density has very little effect on them. It's mainly about the construction of the armor-piercing round. Now, sectional density can affect, and it does have a slight improvement on armor-piercing rounds, but it is not the end-all, be-all for armor-piercing rounds. Moving on to part 3. So I chose what does centered mean and why is it important to understand. So what exactly is centered rounds? So centered means you're bringing grains of powdered metal up to a temperature just short of melting. By doing so, you're creating a weak bond between each of the grains and kind of like, for lack of a better term, gluing them together without any kind of actual adhesive. Understanding why it's important is because in the frangible ammunition manufacturing process, frangible ammo is designed to disintegrate or crumble upon impact to prevent ricochets and injury to yourself or somebody that is close to you. An improperly centered round could cause injury. If it's over bonded, it could ricochet. If it's under bonded, it could bind up and jam inside the weapon. It could jam the barrel. All of these things could cause injury to yourself or the people around you. And then topics like bonded bullets, air resistance, projectile deformities, how does projectile expansion affect the transfer of energy, what does centered mean, what is sectional density. All of these are important for an average gunsmith to understand because all of these can help you troubleshoot any kind of weapon system. So if somebody had a malfunction or there was if it happens, unfortunately, a catastrophic malfunction, you can kind of deduce what happened, where it happened, and what might have caused it to happen to assist you in fixing the weapon system or helping determine what actually happened in the first place. Thank you. That concludes this topic.